This is another lesson in integral calculus, partial fraction part 1. The technique of integrating by partial fraction decomposition will arise, or sometimes it will arise, when you are working with the integral of rational functions. For example, this rational function is an improper rational function, just like your improper fractions, because the degree of your numerator is greater than the degree of your denominator. If we shall do the actual division, it will give you this result: 4x squared minus x plus 1 divided by x minus 4 is equal to this: 4x plus 3 plus 4 over x minus 1. Instead of getting the integral of this function, we will get the integral of this function term by term. And the integral is going to be equal to 2x squared plus 3x plus 4 times ln of the absolute value of x minus 1 plus c. Before we go into getting the partial fraction decomposition of rational function, let us illustrate the idea behind that by getting the partial fraction decomposition of 5 over 8. 5 over 8 is equal to 3 over 8 plus 2 over 8. It is also equal to 1 over 8 plus 1 half. This is the idea behind partial fraction decomposition. When you are given a rational function, you want to produce a list of partial fractions whose sum is equal to your rational function. So for example, we must get the integral of this rational function n of x over d of x dx. What we do is we produce a list of partial fractions whose sum is n of x divided by d of x. That is what we did here, okay? That is what we did here. 4x squared minus x plus 1 over x minus 4 is equal to, okay, 4x plus 3. This is a polynomial function, and this one is a partial fraction. So what's going to happen here is, instead of working directly on your rational function, we will get the integral of our partial fractions term by term. Obtain the integral of x cubed minus 1 over x minus 2 dx. Let us produce the partial fraction decomposition by dividing x cubed minus 1 by x minus 2. And this is the result, okay? And the integral of that is going to be 1/3 times x cubed, okay? This one, x squared over 2. 2 divided by 2 is 1. 4x plus 7 is a constant. You just copy it. 7 times the integral of 1 over x minus 2 dx. And that is equal to ln of the absolute value of x minus 2 plus c. There are many cases to partial fraction decomposition, but in our lessons, I will only pay attention to linear factors. The linear factors here refer to the function in the denominator. We shall have 2 cases. For now, I will pay attention to case 1. These are when the linear factors of your function in the denominator are distinct and they are non-repeating. This is what I mean. N of x over d of x, our rational function, can be written as a sum of partial fractions. Okay? These are the linear factors. Degree 1, a sub 1 times x plus b1 plus Okay, this a sub 2 over a sub 2 times x plus b2, so on and so forth. So these functions in the denominator are linear, degree 1. So when they are degree 1, that means the function in your numerator must be at most degree 0. And that means it is a constant function. So these values here in the numerator, they are constants. So the challenge here is twofold. Okay? The challenge here is twofold. The first challenge is to produce the partial fraction decomposition. And the second challenge is to integrate the partial fractions term by term. Let us produce the partial fraction decomposition of x minus 1 all over x squared plus x. We produce the factoring of our denominator. It is equal to this. X minus 1 over x plus 1 times x. Now, this one is equal to this. Okay, so don't be bothered about how that came about. I will talk about it later in this lesson. So this rational function can be written in this way. It is the sum of two partial fractions. Okay, 2 over x plus 1 minus 1 over x. So these are the linear factors that this technique is referring to. They are the linear factors of your function in the denominator. And so when we must get the integral of x minus 1 all over x squared plus x, we can work on the partial fractions. It's equal to the integral of 2 over x plus 1 minus 1 over x dx. And you know that to be equal to 2 times ln of the absolute value of x plus 1 minus ln of x plus c. Produce the partial fraction decomposition of x minus 1 over x squared plus x. Okay, so this is the example that I just flashed to you. Okay, but this time we will produce those numerators. The numerators are 2 and negative 1. How did that come about? So this is what we do. We will produce the linear or the factoring of your denominator. Okay, and then we will write it in this way. It is equal to a over x plus 1 plus b over x. So the numerators, a and b, they are unknown. We will work on it so that we can find the value of a and b. This is a problem about two unknowns. And you must remember that when you are working on two unknowns, if you want to solve it, you must produce at least two equations. And so together, the two equations in two unknowns is going to be a system of equations. Okay? So we must produce a system of equations in two unknowns. The unknowns are a and b. Okay, so this is what I will do. I will combine this as I would on any ordinary rational function. Okay? The quantity x plus 1 times x, that is your LCD. And then the LCD divided by x plus 1, okay, that's x, times a, it's going to be a times x. Plus the LCD divided by x, that's x plus 1. And then I will multiply it to b. It's going to be this. What I did here is, after I wrote the partial fraction in this way, we don't know yet what a and b are. What I did next is I combined them as I would any ordinary rational function. Go for the LCD. Get the LCD and then do the addition. And we can simplify it in this way, okay? So x is going to be a common factor, okay? So this is equal to this one. And what's going to happen next is you will now compare this function with your original rational function. Okay? Now look at x here. What is the coefficient of x here? It's 1. This means a plus b must be equal to 1. Now, look at the constant term of your numerator. Okay, this is the constant term of our numerator in this rational function. So, this means that the constant term b is equal to negative 1. We can now produce a system of two equations in two unknowns. A plus b is equal to 1 and b is equal to negative 1. Solve for a and b. So since b is equal to negative 1, by substitution, a minus 1 is equal to 1, and that can only happen when a is equal to 2. We already have values for a and b. A is 2, b is negative 1. And so we will just go back to our original partial fraction decomposition. Okay? This integral is equal to the integral of 2 over x plus 1 minus 1 over x dx. 2 and negative 1 are the values of a and b respectively. So it's easy to get the integral of these functions. Okay, so this is just 2 ln of the absolute value of x plus 1. Okay, and this one is just ln of the absolute value of x. Produce the partial fraction decomposition of x over x squared plus 2x plus 3. What we do first is let us produce the factoring of your denominator, and then we write it as a sum of partial fractions. We don't know a yet. We don't know b yet. We must produce a system of two equations in two unknowns. The unknowns are a and b. We will proceed with ordinary addition. Okay, so we will add these two fractions as we would or as we do with any ordinary rational function. Okay, so the LCD is x plus 3 times x minus 1, and then we proceed with addition. Okay, this divided by x plus 3 is x minus 1, and then you multiply it to a, and this is the result. Plus the LCD divided by x minus 1 times b, this is the result. You combine similar terms and this is what happens. It is equal to this. When you get here now, what you will do is you will compare it with your original rational function. What is the coefficient of x here? That is 1. So a plus b must be equal to 1. And look at this. Does it have a constant term? Well, the constant term here is 0. So you have here plus 0. So this one must be equal to 0. Negative a plus 3b is equal to 0. This is the system of two equations in two unknowns. The unknowns are a and b. So right away, you should know how to solve this. You can do this by elimination. You add the two equations, a gets cancelled, and this one becomes 4b is equal to 1, b is equal to 1/4. Now, if b is equal to 1/4, now look at this. If b is equal to 1/4, then a can only be equal to 3/4. We now have values for a and b. A is equal to 3/4 and b is equal to 1/4. We will now fill in the unknowns, okay? Coming from here, okay, we will integrate this. We will replace a by 3/4 and b by 1/4, okay? So the integral of this function is equal to the integral of 3/4 over x plus 3 plus 1/4 over x minus 1 dx. That is equal to 3/4. Okay, this is a constant. 3/4 times ln of the absolute value of x plus 3 plus 1/4 times ln of the absolute value of x minus 1 plus c.